Hello everybody, this is Dr. Vishal Trivedi from Department of Biosciences and Bioengineering, IIT Guwahati. And in our previous lecture, we have discussed about how to pack the column, what are the different precautions you have to take while you are packing the column, and what are the parameters you should consider when you are packing the columns. And now, I will take you to my laboratory to show you a small demo how to pack a column and what are the different precautions you should take. So, in this particular demo, my student the Suram Banesh is going to show you the packing of the column and how to perform the gel filtration chromatography after connecting the column, and how to draw the calibration curves or the elutions of how to monitor the elution of the proteins from the gel filtration chromatography, and how to draw the calibration curve or between the distribution coefficient versus the log molecular weight.
In this video, we will demonstrate how to perform gel filtration chromatography or size exclusion chromatography. There are various methods are available in chromatography to separate different types of biomolecules. For example, if you want to separate based on size or shape, it is called as gel filtration chromatography, which suits the most. If you want to separate the molecules based on their charge, then you can go for the ion exchange chromatography. So these are various methods are available, but in this video we are mainly focusing on the gel filtration or size exclusion chromatography. What is gel filtration chromatography? There is two phases in this process. One is stationary phase, another one is mobile phase. Stationary phase mainly a matrix, cross-linked matrix. For example, we can use dextran, or another name of dextran is Sepadex. This is highly cross-linked glucose molecules. Or we can use agarose. This is also cross-linked. Or we can use polyacrylamides. But in this video, we are showing Sepadex G75. This is the stationary phase we are using. So in this matrix, it contains beads which having small pores. So if you want to separate a mixture of molecules starting from 1 kDa to suppose 200 kDa. So the small molecule which is 1 kDa, it will permeate through or diffuse into the pores in the beads, and the bigger molecule having 200 kDa, it will excluded from the retaining in that portion of pores. So it will elute first and the smaller molecule will retain there, and we have to give sufficient buffer to elute that one. So this is the overall concept of the gel filtration chromatography. It can be widely used as used in separation of proteins, peptides, or oligonucleotides. So in this video we will show you how to pack the column first and what are the buffers required. For gel filtration chromatography, there are two kinds of columns available. One is pre-packed columns and another one is column material, which can be used for the packing of the column. Here we will show you how to pack a column, and also we have pre-packed column. At the bottom of the column there should be a sintered filter in pre-packed columns, which will forbid going of the beads through outlet. So here if you see in pre-packed columns, there is some sintered filter bottom of the column in both the ways. Outlet and inlet both contains the sintered filters. Inlet, which is mainly from buffer inlet, if there is any particles which will obstruct the flow, they will be separated on top. And also the outlet one, which can be used preventing passage of the beads through outlet. So here we don't have exactly syntax filter, but we can use a piece of cotton. So just put the cotton. So now we inserted the cotton. These are the beads we are going to use for packing of the column. These are Sebadex 75 beads. So there are different materials available: sucralose, Sebadex, Separose. These all are derivatives of a carbohydrate material. So here what we will do, this is the overnight solid beads. So you have to take the beads complete pack and incubate, soak it in the water or the buffer. So these are solid one. Now after inserting the this sintered filter or column, you have to wash column properly, at least 2 to 3 column volumes with the distilled water. So if anything it contains like dust or any other contaminating particles, it will remove. Now we directly pour the beads on top of the column. If we close, if you observe closely, you can see the settling of the columns, settling of the beads. As we can see, the beads are settling slowly. So after complete settling of the beads, then we will put some filtered kind of thing or some piece of cotton on top of the beads. Then we will load the sample. As we can see, now the packing is over. Now what we have to do is we have to equilibrate the column with the 0.05 molar phosphate buffer. So we'll just add phosphate buffer. And drain the any unbound solvent. So here, after equilibration of the column, we will load the sample. After column packing, you have to check the efficiency of the column. So for every column, the parameters V0, that is void volume, and VT, total volume, and V, elution volume, it differs. So for checking of the column efficiency, we have to use 0.2% of total volume of the column acetone we will load. So we have to observe the elution at 280 nanometers. From this we can calculate number of theoretical plates N. So the maximum number of the theoretical plate means the more the efficiency. For calculation of any unknown protein's molecular weight, we should know what is the VT, V0 and VE. VT is the total volume of the column, means the buffer occupied in the spaces of beads, and also the buffer in between the beads. So that that will be total volume. The void volume is the buffer in between the beads. Elution volume is where the elute. Suppose we are eluting protein. So at what volume it is eluting, that is called as elution volume. So for estimating the void volume, we can use blue dextran. So first we have to cover top with the piece of cotton, then we will load the blue dextran. After loading, sample loading, we will start collecting the buffer till blue dextran completely eluted. That will give the void volume. So now we loaded the blue dextran. We will add the buffer, then we will elute. So as we can see, the blue dextran is passing down. So we have to replenish buffer continuously, and we start collecting the eluted volume. So after complete elution of the blue dextran, we have to measure the volume, and that volume gives us void volume. Now the blue dextran completely eluted. It is around 18 to 19 mm. So now we got void volume. Now what about total volume? Total volume consists of the packed volume of the beads. Total packed volume of the beads. So it is around 25 ml of beads are there. So that means total volume is 25 ml. So with these values, after eluting the protein, suppose if you are using some unknown protein, you have to calibrate with for known proteins. Then you have to construct a calibration curve between the partition coefficient, which is calculated by elution volume subtracted with void volume divided by total volume subtracted void volume. That will give partition coefficient, and on x-axis you have to take log molecular weight. Once you plot, you will observe some correlation. Based on that, you can calculate unknown proteins molecular weight. So this is the gel filtration column attached to protein purification system. So here what we will show you, we will inject the blue dextran and BSA and show their pattern, how they are eluting. This blue dextran gives wide volume of the column, and also BSA gives actual elution pattern. So if you run few more proteins with known molecular weight, we will get the calibration curve. With that we can calculate unknown proteins molecular weight. So this column is equilibrated, as we can see here. When we introduced into buffer after removing 20% ethanol and water also, so we can see this one corresponds to, blue line corresponds to 218 nanometer, which is relevant to protein 1. So we can see there is a initial spike, but gradually the curve flattened. So that means there is no contaminants, and now the column is ready to inject the protein. So what we will do, we will inject the protein, and we will show how to inject protein also. Then we will show the pattern they are eluting. So here we will end the program. So we will start the new program. System flow will keep 0.5 ml per minute. Insert flow path, column position at 1 and downward flow. Insert monitors. We need 3 different wavelengths: 215 for peptide bond, 254 for nucleic acid, and 280 for aromatic amino acids. And we have to set the alarms also. We'll set this 3 and this one 01. Complete system pressure 3 and this one 01. So we will inject the protein now, then we will see how it is. This is the port where we are going to inject the sample. So once we will inject this one, and execute, inject. So this is a pattern of injected components. This one corresponds to the blue dextran, and it gives the void volume of 8 ml. As we can see here, it corresponds to 8 ml. So there is no proper resolution between BSA and the blue dextran. This corresponds to 8 ml, which is blue dextran, and this one is the 9.2 to 9.5. This corresponds to the BSA. So once this is finished, we have to run another one column of in buffer to remove any other proteins, and after that we will keep it in water, so to remove any kind of salts if present. Then we will keep in the 20% ethanol. We will run at least one column volume, so that directly we can use to preserve the column. After that we have to purge with the 20% ethanol complete system, so that there is no contamination or bacterial growth if you left for few days also. So this is all about gel filtration chromatography. So we will show you how to analyze the result. So once the gel filtration run is over, we have to analyze the results. So this is the software we will use for the evaluation purpose. So we have to open the chromatogram which you want to analyze. So we already opened. This is the chromatogram we run recently. So we have to analyze peaks. So peak integrate option is there. So just say which one you want to analyze, UV 280 nanometer one or 215. We have only 281, so that's, let's say, analyze. So as we can see, it gave the retention volumes of the peaks and also the area and height of the peak. These values can be used for constructing calibration curve. This one belongs to blue dextran and this one is for BSA. So in a summary, in this video we showed how to run a gel filtration we showed manually how to pack the column with the beads and also connecting through instrument. So hope this will help for your research, to improve your research.
So, in this demo, the Banesh has discussed many parameters and many aspects related to column chromatography. Now, once you pack the column, one of the crucial parameter is that how you are going to do the quality testing or quality checking onto your chromatography column before you start using it for your experiments. So, one of the crucial parameter is that you should be able to know the different type, you should be able to calculate the different parameters related to a gel filtration column, and that those parameters should be okay with the standard columns. So, what are the different parameters? So, if you pack a gel filtration column, you have the multiple parameters. For example, you are going to have the VT, you are going to have the VO. Okay. So, these are actually the two parameters you can be able to calculate for your column, and that should actually come. So, one of the easiest way of calculating the total volume. Now, one of the, so how to calculate the total volume? If you remember, when the KD is equivalent to 1, okay, the VE is equivalent to the VO plus VI, which means that if I take a molecule and with VO plus VI is equivalent to VT actually. So, if I have to calculate, or if I want to calculate the VT of a column, what I have to do is I have to take a molecule which is immiscible to the aqueous solvents, and that can be detectable using the standard spectroscopic methods, and that should be present at the center or at the end of the pore, because that is the molecule who is going to travel all the way up to the column, and it is going to give you a travel distance which is equivalent to the VT. So, what are these molecules? These molecules are going to be the smallest molecule possible. So, in the gel filtration chromatography, what is the smallest molecule? The smallest molecule is water, okay, because that is the smallest possible, right. You have the water which is of a molecular weight of 18 Dalton, but if you add the water, you will not be able to distinguish the water which is present in the mobile phase versus the water which is you are going to inject into the column. So, because of that, you have to take a molecule which is of the smallest in range, but that should be immiscible or should be detectable from the water. So, in that case, what you do is you take any organic solvent. For example, you can take the acetone. So, if you take the acetone and if you inject very small quantity of acetone into the column, the acetone is going to be go and filled at the bottom of this pore, and then it will take the total travel length of the column, and it will give you the VT of the column. So, you are going to have the VT which is being calculated experimentally. Then you can also be able to calculate the VT of a column simply by measuring the volume of the beads by theoretical method. So, the theoretical VT should be closer to the experimental VT which you are going to calculate after flowing the acetone. If that is the case, that actually will ensure that you have packed the column nicely and the column is free of the defects. Now, once you have packed the column, you are also going to face different types of problems when you are performing the gel filtration chromatography. So, what are these problems? First problem is you are going to see a back pressure. So, when you run the columns, they actually because irrespective of whether you want it or you do not want it, all the columns are actually having a filter on top, okay, and then you have the filter at the bottom, and in between you have the your material being packed. So, this column, this filter is always getting the some kind of proteins or other kind of factors are being stuck to these filters, and because of that you are actually going to have the back pressures. So, what you have to do? You have to clean these filters with the help of the, you have to use some cleaning agents, and you can still, you can remove these filters and clean it. So, that actually will take care of the back pressure problems. Then you have the clogging of these columns, which means the proteins are going to be present onto these filters, and those filters are actually having the small pores through which only the water can be able to pass through. So, if you have the proteins getting through those pores, proteins also get bind to these pores, and that is how you are actually going to have the clogging. If you have the clogging problems, then what you have to do is take out these filters and treat it with the acid, or you can treat it with the NaOH or the alkali. So, in the acid you can treat it with the HCl. When you treat it with the HCl or the NaOH, the proteins which are present into these pores are going to be damaged, and that is how it is going to be clear off. If that is not good enough, you can still be able to treat it with the organic solvents as well, which are not going to affect the filters, and that is how it is going to clean your filter. And then you can put the filter back, and it should definitely going to take care of the back pressure as well as the clogging problems. The third problem is that when you are going to see the precipitation of the protein. So, what happen is, sometime when you load a protein, suppose you are doing some experiments and you do not know how the protein is going to behave when it will go to the gel filtration column. So, suppose I loaded a protein solution, okay, and as soon as it enters into the gel filtration, because one of the thing which happens in the gel filtration is that it dilutes the protein solutions. So, once the protein solution is being diluted, it precipitates, because the protein is not stable or some other issues. So, once the protein gets precipitates, it actually is going to distribute throughout your column, okay, instead of being localized into the few beads or few pores. Because of that, irrespective of whether you, and the other issue is, first of all, it is going to be distributed throughout the column. The second is, it is actually going to be bind to the pores, okay. So, it is irreversibly going to stuck to some of the beads. So, what happen is, if that happens, this column is no longer be useful, because the protein is going to be keep eluting from this column, irrespective of whether you have run it for 1 column volume or 2 column volume. The second is, because the protein got stuck into the beads, it is useless. So, in that case, what you have to do is, you have to flow the small quantity of protease, okay. So, if I want to do that, what I will do is, I will take the pepsin, okay. I will equilibrate this column with a buffer which is maintaining a pH 2, and then I will inject the pepsin and let the pepsin to go and incubate, and then what I will do is, I will take this column, take out from the chromatography system, tie it up and keep it in room temperature, which means I will leave it on my bench. And what will happen is, this pepsin will going to be diffused, because as soon as you are not connecting it to the machine, the protein is going to diffuse, because even if the pepsin is present in the first layer of your column, it will come out from the beads, it will diffuse, and it will diffuse throughout the column, and ultimately what will happen? The pepsin is going to chew up the these proteins, and they will be able to degrade. So, it will degrade all the proteins that are being stuck or what is being present in the different parts of the column, and that is how it is actually going to remove these precipitated proteins, irrespective of whether you have the back pressure problem, you have the clogging, or you have the precipitation of the proteins, and you are either working with the filters or you are doing the protease treatments. once you are done with this, you have to recalibrate this column to utilize this column for monitoring the molecular weight of the unknown proteins. So, that is very very mandatory that whatever the treatment you do, you have to, because all these treatments are actually disturbing the packing of the columns, and that is why it is actually going to change the void volume and total volume and all other parameters. So, that is why it is important to recalibrate and recalculate the relationship between the KAV versus log molecular weight. Now, let us discuss about the operation of the gel filtration chromatography. So, in the gel filtration chromatography operations, the first is we have to do a column packing. Once the column packing is over, then you have to do the quality checking simply by calculating the total volume either by flowing the small amount of acetone, and the third is you have to prepare the samples. So, you have to prepare the sample in the same way that sample is prepared in the mobile phase, and it should be free of suspended particle to avoid the clogging of the column. The most recommended way is apply to inject the sample with a syringe, so that it will get into the loop, and then the loop is going to inject the sample into the column. Elution. So, there is no elution as such when you run the, so there is no gradient of salt or something to elute the samples. Once you do, if you flow the mobile phase, the column is, the molecules are going to be eluted from the column. Only thing you have to remember is that the in the gel filtration column, everything is going to be eluted by the one column volume, because the Kd is going to be 1 for most of these molecules, and the any molecule which has the Kd of 1 is going to be eluted even in the one column volume. So, you cannot have the Kd more than 1, because if you have the Kd of more than 1, then that molecule is going to stuck to the column and that will not elute. So, for a standard molecules, those molecules which are going to follow or which are going to be separated by the gel filtration chromatography will not going to have the Kd more than 1. So, that is why the one column volume is good enough to elute the molecules from the column. Once you are done with the chromatography, you have to do a column generation. So, after the analysis of analyte, gel filtration column is washed with the salt containing the mobile phase to remove all the non-specifically adsorbed protein to the matrix. The column is then equilibrated with the mobile phase to regenerate the column. If you are not planning to use the column, then the column has to be stored in alcohol, and it has to be preserved, or it has to be stored in a 4°. Now, here you have to remember, if you are storing a column in 4°, and suppose you are operating this column at 25°C, which means it is on room temperature, it is always important that you store the column in 4°, fine, but if you want to operate, you have to bring it in 25° for at least for some time, and then only you should use, because when you change the temperatures, you are actually also going to affect the packing of the column, and that eventually is going to affect the separation profile of the different proteins from this column. So, that is why the temperature has to be constant, and it should be remain constant throughout your performing the gel filtration chromatography. So, with this I would like to conclude our lecture here. In our subsequent lecture, we are going to discuss about the application aspects of the chromatography, especially designing the different types of experiments. Thank you.